hopefully you've tried this worksheet by yourself to see what you could get and worked all the way through it. Maybe you had some trouble with it. Maybe it went very, very easy for you. Let's hope so. But if not, we're here to help. Okay? So, we're basically wanting to simplify this. You can read the instructions there above. Simplify each expression completely using the properties of exponents. Answers should have positive exponents only and all numbers evaluated. Let's see what we can get. Okay, start out with a to the negative 7. Remember, we want all positive exponents. In order to get this to have a positive exponent, we can use the property that basically says we can convert this to 1 over a to the 7th power. Now we have a positive exponent here, and we're good to go. Number 2, pause where needed, and comment below on the YouTube if you get stuck or have any questions. No problem. Or reach out by email, whatever you feel up to. Alright, in this one it says 21c raised to the 18th power, all raised to the negative 1. Now here, we want to get rid of negative exponents. Now all of this is in parentheses and raised to the negative 1 power. So the easiest way to get rid of that negative exponent is just put all of that down in the denominator. There's nothing else to simplify here at all. That's it. Might look complicated, but one simple step and we are done. Now step 3 plays on that 0 exponent property. Anything raised to the 0 is, this is where you say 1. So 3d squared, all raised to the 0 power, should just be 1. Because anything raised to the 0 is 1. Alright, now here I have 5 times x raised to the 0 power times y raised to the negative 1 power. Now anything raised to the 0 is 1. So if we start out with the first simplification step, we could just reduce this x raised to the 0 power to a 1. Now we still have this negative exponent on the y here. We have y raised to the negative 1. We don't want that. We want all positive exponents. 5 times 1 is 5. And if I use my negative exponent property here, and I want to get rid of that negative exponent, I just need to bring my y to the bottom. Now you could put a 1 exponent on that y here if you want to, but you don't really have to, because anything raised to the 1 power is itself. And we're done. We've gone through the first 4 quite quick. Let's look at the product of powers property here. Now here I have a to the 7th times a to the 12th. We know that if 2 bases are the same and they're multiplied, we can just add their exponents. So this is essentially just a to the 7 plus 12 in the exponent. Now 7 plus 12, that is 19. So we really just have a raised to the 19th power. Alright, in 6, we still have this same product here, or product of powers property here, but here we have 3 c's. Because they're all the same base, I can just add those exponents. So this should just look like c raised to the 3 plus 8 plus negative 5, right? Which is simply just minus a 5. Okay, 3 plus 8 should give us 11. 11 minus 5, or if I'm doing too many steps for you, I guess I'll slow down. But 3 plus 8 is 11. And then we're essentially just subtracting 5 next. Should render us 11 minus 5 is 6. And we're done. Now if I look at number 7, we get a little more complicated. Okay? We do have d's here. We have 3 d's. But we also have a 2 and a negative 4 that are multiplied. Okay. So the first thing I'm going to do is work with the constants. 2 times negative 4 is negative 8. Now, all these d's are obviously the same base there. So I can just add the exponents of all those. So this should give me negative 8 times d raised to the 7 plus 9 plus 5. Now, 7 plus 9, I'll do it step by step. 7 plus 9 is 16. Hopefully you can combine some steps here. Maybe do all the additions at one time. But I'll take it step by step just to make sure we're getting it. And then we have 16 plus 5, which is 21. So I have negative 8d raised to the 21st power. Now, I know we don't want any negatives here, but when it says it didn't want any negatives, it was talking about the exponents. It's not worried about the negative out in front of the 8. Okay, so don't try to do anything extra there. It's okay that the 8 is negative. We just don't want any negative exponents. Now, in number 8 here, I have 9 times x raised to the 10th power times y raised to the 3rd power times negative x raised to the 5th power times y raised to the 3rd power. Now, we should be able to combine the bases of x together and combine the bases of y's together. Okay. Now, I'm also going to multiply this 9 times this negative here, because technically that's just a negative 1 placeholder. So my first step here, I'm going to reduce this to negative 9 times x, and I should be able to combine these x's. I'm going to do a couple steps at once because we're in the last question of this subset here. But this is an x raised to the 10th, this is an x raised to the 5th. I'm just going to add those exponents. And then I'm going to do the same with the y. Here I have a y raised to the 3, and here I have another y raised to the 3. Just going to add those exponents. So that now we are able to simplify this down to negative 9 times x raised to the, should be 15, right? 10 plus 5 is 15. And then 3 plus 3 is 6. So I should have negative 9 times x raised to the 15 times y raised to the 6th power. Easy. We got this. Got this. Now let's look at the quotient of powers property. Okay. Now, in this case here, I have a raised to the 12th power over a raised to the 7th power. We want to reduce this. Okay. Now keep in mind that if I move this 7 to the top, it becomes negative. So essentially, what I would be doing if I did that would be converting it to this. a to the 12th times a to the negative 7, which we could then convert to a to the 12 minus 7, which should give us a to the 5th. Now, you don't have to do those intermediate steps. If you can recognize the quotient of powers property, you can jump straight to saying a to the 12 minus 7 equals a to the 5th, because they're on opposite sides of that division sign, so I can just subtract them. Alright? Now, number 10 gets a little more complicated, because in number 10, I have 6 c to the 3rd over 3 c to the negative 5. First thing I'm going to do is mess with my constants here. What's 6 divided by 3? 6 divided by 3 is 2. That's going to give me 2 times c to the 3rd over c to the negative 5. Now, in this first one, what we did was subtract 12 minus 7. We did 12 minus 7. Here, my exponent on the bottom is already negative. So technically what I'm doing here is doing 2 c to the 3rd minus a negative 5. When I move that 5 up, or that negative 5 up. We know that minus a negative turns into a positive. So I'm really looking at 2 times c to the 3 plus 5, where 3 plus 5 is 8. So my answer is 2 times c to the 8th. A few little extra steps there, but not too bad. Now let's look at number 11. Getting progressively harder here. Now I have 2 times d to the 7th over negative 4 times d to the 9th times d to the 5th. Okay. In my first step, I'm going to simplify here. I basically have a fraction, a 2 over negative 4. What does that simplify to? Hopefully we can jump and simplify that to negative 1/2. Where basically this 2 cancels this out. We cancel a 2 out of here. We're left with a 2. Okay. So we'll be left with d to the 7th over negative 2 d to the 9th times d to the 5th. Clearly not done yet, though. Okay. Now let's combine these d's in the denominator. So I'm going to leave my d to the 7th alone in the numerator. I'll leave my negative 2 alone in the denominator. And because these are side by side and multiplied, I can just add their exponents. So this is the d to the 9 plus 5. 9 plus 5 is 14. So I'm left with d to the 7th over negative 2 d to the 14th. Now, here is where we do something a little different. Because if we remember back to our original instructions, we do not want a negative exponent in our answer. If I were to bring this 14 up and subtract it, 7 minus 14 would give us a negative 7. That is not something I want. Typically in these scenarios, we move the smaller exponent. In each scenario we've done so far, the smaller exponent has been on the bottom. In number 9, 7 was smaller than 12, we moved it up. In number 10, negative 5 is smaller than 3. Okay, think about that. Negative 5 is actually smaller than 3. If you have 3, you have way more than somebody that has literally negative 5. Okay, so we moved the negative 5 because it was the smaller number, right? In this case, the smaller number is 7 and it's in the numerator. So we need to move it down if I want to keep a positive exponent. So now what we're looking at is 1 over negative 2 times d raised to the 14th power minus that 7. So I brought that 7 down from the numerator. I still subtract it because it crosses that division line. And it simplifies down to 1 over negative 2 d to the 7th power. Okay, let's look at number 12. Like I said, number 11 was a little more complicated, but we were able to get to our correct final answer. A lot going on here in number 12. I've got 9 times x raised to the 10th power times y raised to the 3rd power all over negative x raised to the 5th power times y raised to the 3rd power. Now, here is where if you're a little slick and you're watching what you're doing, and you remember some basic properties, you might be able to simplify this real quick. Alright, what do I mean by that? I'm looking at this. Same thing on the numerator as I have on the denominator, I can cancel it completely out. Okay? I have a y to the 3rd in the numerator and a y to the 3rd in the denominator. I could technically just cancel those because they're the same thing. 5 divided by 5 is 1. 10 divided by 10 is 1. Anything divided by itself is 1. Y to the 3rd divided by y to the 3rd cancels itself out and is essentially just 1. So in my first step here, I have already done a quick reduction of my problem. Technically, you could use your exponent properties there, subtract that 3 up, and you basically wind up with a y to the 0. Anything to the 0 is 1. Or you could just notice that they cancel. Now I just have to cancel out some of my exponents here in my x. 5 smaller, so I'm going to bring it to the top. So I'm basically looking at negative 9x to the 10 minus 5. 10 minus 5 is just 5, so I'm looking at negative 9x to the 5th power. And we're done reducing that one. Now, for those of you freaking out that this negative was in the denominator and you think that I have to keep a division sign and a 1 there, you don't have to, because anything divided by 1 is itself. Anything divided by negative 1 is just negative itself. So that's how we wound up taking that 9 to a negative 9. The negative really doesn't matter where it's at in that multiplication problem, as long as you keep it with it. Put it on top or the bottom. Let's look at a power of a power property here. See what we get. So number 13 says a to the 3rd raised to the 4th power. Now, power of a power, we multiply. Keep that in mind. Power of a power, we multiply. What that means is essentially all I have to do here when I have a to the 3rd to the 4th is just multiply the 3 and the 4. That simplifies to a to the 12th. Power to a power, we multiply. So if I go on to number 14, c to the negative 1 times 3, or raised to the 3rd power, I'm just multiplying. See how my mind jumped straight to it. Power to a power, I multiply. So I'm really just getting c to the negative 3rd. Keep in mind, we don't want negative exponents here. So I do need to do a little extra step. Bring that down to the denominator so that I can change that exponent to a positive number, a positive 3. But all I did was negative 1 times 3 to get my exponent there. Jumping to number 15, d to the 5th power to the negative 2 power. Power to a power, I multiply. That should simplify to d to the negative 10. Remember, I do not want a negative exponent, so I'm going to bring that down to the denominator and change the exponent to a positive. Okay. Whew. We've got some parentheses going on in this one. Number 16. 6x to the 3rd times y times x squared to the negative 2. Alright. First thing I'm going to do is take care of the power to the power. Okay, so I'm going to leave the 6x to the third y alone. And I'm going to say power to a power I multiply. So I need to do 2 times negative 2. That's going to give me x to the negative 4. Okay, now essentially this is just multiplication at this step. So I can simplify it down to 6x to the third y x to the negative 4. And if I'm multiplying here, I can combine these same bases of x here by just adding their exponents. Okay, so this is going to tell me that this is 6x to the third plus negative 4y. Okay, now 3 minus 4 is negative 1. So I'm going to get 6x to the negative 1y. Obviously, don't want any negative exponents, so all I have to do is drop that x down to the denominator, and now I have no exponents that are negative. I have my final answer. Step by step by step by step. You don't have to do it as fast as me. I have been doing math probably longer than a lot of you have been alive. So don't expect yourself to be bang, 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 quick, fast, and in a hurry on all these steps. Remember, you're practicing. You're building your foundation. I've had my foundation for a very long time at this point. And now I'm just making myself feel old. But don't expect yourself to be able to go as fast as I can solving these problems. But make sure that you know why you're doing each step and that each step makes sense to you. Take some time to practice it and work on it. Okay, like I said, we start out really easy in this class, but we build up to some harder and harder foundation style problems, right? Addition, multiplication, first couple lectures might have been kind of easy for you. I'm guessing it's probably getting a little more difficult at this point with these properties of exponents. Okay, so put some time into it. Practice makes perfect. Understand your properties, know how to use them, and get familiar with doing them in problems. Okay. Let's see what we got next. My pen is just giving me a fit these days. 17. Come on, pen. Nope. All right. Pen is currently no. All right. So the first one says for number 17, 8 times a to the fifth, all to the second power. Okay, or all squared. Now keep in mind, because this is in parentheses, this square needs to go to both of these terms. So technically, this is the same thing as 8 squared times a to the fifth squared. Because that squared needs to go to both of those terms. Now 8 squared is 8 times 8, which is 64. And if I have a power to a power on this a base here, all I'm doing is 5 times 2. 5 times 2 is 10. So the final answer should be 64 times a to the 10th power. If I have an exponent here, whatever's in that parentheses has to get that exponent. Each of those terms do. So in number 18, when I have parentheses 2c to the negative 1, all raised to the negative third power, I need to apply that negative third to both of those terms. So I need to have 2 to the negative third, and I also need to have c to the negative 1 to the negative third. Now if you want to, of course, you can put that 2 in parentheses as well. That's fine. Just a notational thing. Still works out the same way. Now, we want positive exponents in our answer. And I don't know how many of you can tell me what 2 to the negative third is off the top of your head without using a calculator. So instead, let's convert this to a positive exponent so that maybe we can figure out what 2 to the third is in our head. So what I'm going to do in order to do that is I'm going to put that 2 to the negative third in the denominator so that negative third will turn positive. Then I'm going to say c to the negative 1 to the negative 3, that's power to a power, so I multiply those exponents. Negative 1 times negative 3 is positive 3. It gives me a c to the third in the numerator. Okay, let's simplify this out where we get rid of this number raised to a power. So I'm going to keep the c to the third in the numerator. But what is 2 to the third now? 2 to the third is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Hopefully we can do some of these simple exponents in our head. Alright, number 19. I've got negative 2 times d to the 10th, all raised to the negative 2 power. So this is going to give me negative 2 I'm going to put that in parentheses primarily because it's got that negative out in front. You'll see why here in just a second. But I'm going to raise that to the negative 2 power, and I'm also going to raise that d to the 10th to the negative 2 power. Okay? Alright, so once again here, I have this negative exponent. That's something I really don't want to have. The best way to get rid of it is to move everything to the denominator. They're both negative, so I need to move both of them to the denominator. So I'm going to use 1 as a placeholder in the numerator. Alright, that's going to give me negative 2 squared on the denominator times d to the 10th squared in the denominator as well. Okay? Now, negative 2 squared. Negative 2 squared is negative 2 times negative 2. Negative 2 times negative 2 is 4. Okay, so that negative actually kind of turned into a positive when we squared it, right? Keep that in mind. And then here I have a power to a power. I have 10 squared. Okay, so I have d to the 10th squared. That 10 and that 2 need to be multiplied. Power to a power, I multiply. So I'm really looking at d to the 20th. So my answer here is 1 over 4 d to the 20th power. Set a little more complicated as we go. Now let's look at number 20. Number 20 says 4 times x squared times y to the 3rd to the negative 2 power times negative x to the 10th power squared. Whew. Alright, let's look at it. Let's look at it. The first thing I'm going to recommend doing here is I'm going to take this entire term and I'm going to put it in the denominator so I can get rid of this negative. Okay, so I'm going to keep and put this negative x to the 10th squared in the numerator, and I'm going to put this 4x squared y to the 3rd squared in the denominator, because I can drop off that negative when I move it down. Alright, now let's work on it piece by piece. Negative 1 squared, because that's essentially what's hiding out front here with this negative in front of the x. Negative 1 squared is positive 1. So I can essentially drop that negative off up front. Then I'm just left with the power of a power. So x to the 10th raised to this 2 is going to be 10 times 2, which gives me x to the 20th power out here. And like I said, it turns positive because this negative 1 out front also has to get squared, and negative 1 squared is positive 1. Hopefully you followed me there. If not, take a minute, go through it. Now, this squared here also has to get applied to all of these terms here. I'm going to change my color here. So this this 2 squared, 2 in that squared location needs to get put to all 3 of those. Okay. Which means, what's 4 squared? Well, 4 squared is 16. Power to a power here. I've got x squared to the power of 2. That's going to give us x to the 4th. And then here I have y to the 3rd power squared. It's going to give us y to the 6th. Now, obviously, we're not done because we still have 2 x terms here and we want a single x term. So, in order to combine those, I'm going to move this up and subtract it, right? So we're going to have x to the 20th power minus 4 over 16 y to the 6th. We do the final reduction step here. 20 minus 4 is 16. We have x to the 16th power over 16 y to the 6th. Like I said, we can make this as easy or as complicated as we want it to. We can work with a lot of exponents all at one time. Okay? Alright. Now, I'm going to go all the way up to 24. I'm going to leave the more practice and mixed properties with you. What I want you to do is I want you to go through those more practice and mixed properties and the bonus questions here. Try those on your own and email me if you have questions or if you want me to check your answers. Before we get there, let's go ahead and do the power of a quotient property. Okay. Number 21. I have a over 2 raised to the 4th. Now that 4th needs to go to both of those terms. So it needs to go to the a term. And it also needs to go to the 2 term. Now, all I really have to do here is simplify this 2 to the 4th because we want everything in terms of basic numbers, if possible. Okay, I'm going to leave the a to the 4th alone. Can't be simplified. But what is 2 to the 4th? 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And we're done. Let's look at number 22. I have 25c to the negative 1 over 5 all squared. Now, this squared needs to go to all of these terms. The ones in the numerator and the ones in the denominator. Okay? So we're technically taking this squared and putting it to all three of these terms. Alright? Now, if you had to square in your head 25, that'd be 25 times 25, that might be something that's difficult for you. So keep in mind that with these problems, you don't always have to force through the properties to begin with. The first thing that I would do here, before I tried to force through my quotient property or power of a quotient property here, is I would see if maybe there's a simplification step. Is there something easy we can do here to make this squared just even easier than that? What's 25 divided by 5? It's 5. So technically, I could reduce it to this right off the bat, because 25 divided by 5, this piece right here, I could simplify that down into just that 5. Now I've just got to distribute this 2 here, this exponent of 2, to both of those inside terms. So now I'm looking at 5 squared and c to the negative 1 squared. 5 squared is 25. C to the negative 1 squared, negative 1 times 2 is negative 2, gives us c to the negative 2. Keep in mind we don't want negative exponents, so we're really just looking at 25 over c squared. Saved ourselves from having to square 25 because we did a simple simplification step in our first part of our problem. You don't have to force the properties through just because it says you use the properties. Okay? If you can see a simple simplification step that's going to save you a lot of work in the long run, go ahead and do that before you use the property. That is okay. Just because it says use this property doesn't mean that you have to, bam, force it through on step number 1. You can simplify and then use the property. Alright, which leads us to 23. We could force through right out the bat. We could force through and distribute this 2 to every single one of these terms. I have negative 2, d to the 11th, f to the 5th, all over 4d to the negative 2, f squared, all raised to the square, or the 2. Right? I could distribute this 2 to the negative 2, to the d to the 11th, to the f to the 5th, to the 4, to the d to the negative 2, and to the f to the 2 if I wanted to. Or I could do a simplification step first, and then only have to distribute it maybe 3 times instead of 6. Okay? What do I mean by that? Well, let's start out with the constants. What is negative 2 over 4 reduced to? Negative 2 over 4 reduces to a half. Negative a half of that. So I can already start out with this reduction. Negative 1 over 2. And I'll go ahead and redraw, but extend that line. Okay. Now, I have d to the 11th over d to the negative 2. Now, if I move that d to the negative 2 up, that negative 2 actually becomes a positive 2, and I'm looking at d to the 13th in the numerator. I'm combining and doing steps here really fast, because we're on number 23, and these are properties that we have already reviewed at this point. If you need to take it step by step there, when you're moving these exponents now, by all means, get some scratch work out and do it step by step. But like I said, once we've reviewed some of these properties, I expect you to review them on your own and practice with them on your own, so that as we go forward, I can actually implement those without having to do so many steps. Now, same thing with the f. Okay, I have f to the 5th over f squared. I'm going to move that 2 up and basically wind up subtracting it. Essentially what I did here on the d was I wound up adding 2 because I did the opposite sign. Here I'm going to do the opposite sign here and subtract 2 for the f. So I wind up with f to the 3rd power. And remember, all this is still squared. Okay? Alright, now, let's look at this. I got to square everything here. Okay? Which means that the square, change color on my pen real quick, the square needs to go to the negative 1, needs to go to the d to the 13, needs to go to the f to the 3rd, it also needs to go to the 2 down here as well. Get my handwriting a little bit. Negative 1 squared is positive 1. Okay? I'm just going to drop that completely off. 2 squared is 4. Okay, I'll put that in the denominator. If I'm doing power of a power here, then I'm doing 2 times 13 on that d. 13 times 2, or 2 times 13, is 26. I'll end up with d to the 26. And here I've got f to the third, raised to the second power. 3 times 2 is 6. So in my simplified form, I have d to the 26, f to the 6, all over 4. Very nice. Very nice. Alright, last one we're going to do. Like I said, I'm going to leave the more practice and mixed problems with you and the bonus questions with you as well to really give you a challenge and see if you can knock those out. If you care to know the answers to those, by all means, reach out to me by email to check your answers. But I'm going to leave it up to you, because this is a class that's supposed to prep you for the next level. And in order to do so, you've got to be willing to try stuff on your own. Alright, simplify number 24 out. Negative 2x squared all over 3xy squared raised to the third power. Let's simplify this top inside term first. Okay, so I'm going to distribute this squared to the negative 2 and to the x, so that I get negative 2 squared is 4. And that squared is also going to go to the x there. We're going to have that over 3xy squared all to the third power. I'm going to simplify this interior here, because I can cancel this x with one of these, because all I did basically was subtract 1, because exponent is supposed to be a 1 there. If it doesn't have an exponent, it's assumed to be 1. So I'm basically just doing 2 minus 1 there, which reduces it to a 1. So I wind up with a 4x over 3y squared, all to the third power. Okay, remember that whole thing's in parentheses. Now, 4 to the third, x to the third, 3 to the third, and y to the sixth, because 2 times 3 is 6. The only thing left to simplify here, I'm running low on space, so I'm going to write here, is I have to figure out what 4 to the third is and 3 to the third is. 4 to the third is 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. So I get 64x to the third. Then I got to figure out what 3 to the third is. 3 times 3 is 9 times 3 is 27. Y to the sixth. And we're good to go. That's it. You do check to see if it reduces. The 64 over 27 reduce. It does not. Good to go. We are good to go. So, go on, try on your own the more practice and mixed properties and the bonus questions. See what you can work through and get. You can check yourself. You know, I'm sure y'all have some photo math that can probably check it for yourself on your own anyway. But if you do want me to check the answers with you, by all means, I encourage you to reach out to me by email. Let me know how you're doing. Let me know that you're continuing on and practicing with me. And like I said, if you would like me to check them, send me your answers. Send me a picture of your work, your solutions. We'll let you know how they turned out. Otherwise, check them on your own. Not a problem. Not a problem. I know some people aren't as social as others. It's okay. I'm here to help. I'm here to teach. I'm here to help prepare you for your next steps. I hope that you gained something from the lecture today, and I look forward to seeing you next time.